welcome everybody. And I would just like to start with an introduction of the project to show the methods and the mindset we followed during this semester. Just a quick slide to bring us back on the geography of Madagascar. We are in the highlands of about 1,250 meters over sea level. This is a number that has been used more and more in the project. Also, all of the students know exactly the altitude. Very important also is to notice this rain chart. We have a 2-season change between the rainy season and the dry season. And this led us to understand the whole site with a dry and wet side, the agricultural fields, for instance, dry and wet, the fluvial systems, here the Sisson River, that also dries up sometimes completely. And the broader sense of what is happening in our boulders that we are analyzing, the brick mining to create bricks for construction that leads to overuse of soil material, which then creates these degraded areas. We wanted to use a science design loop within this project. That means having different inputs. I would like to name 3 main scientific inputs that we use. 3D model, we call it point cloud model. It's an epistemic model because you can extract all the information from it. It has a centimeter precision. Then we used a simulation to actually understand how water moves within these topographic structures. Then an expert exchange with guests and different lectures. I can show quickly the schedule that we followed during these weeks. And you see the red dots, actually all the moments where we asked people to give some inputs. Nicolas Saliou gave an input on agronomy. Then there was Christophe giving water issue lecture. There was Marie-Tina Asso that gave a lecture on settlements. Nele gave a lecture on the architecture, on her project. Then especially the seminar week was a very intense moment to understand how is the feeling over there. A very important exchange between local culture, getting acquainted with students from 2 institutes over there, scanning in the field, and having a whole workshop week working together and exchanging ideas. The whole project was introduced first with a remote investigation studio that used this laser scanning technique. So here you see a laser scanner that was used to create recordings locally to understand how topography works, how water would fluctuate through it, which led us to have these informed models. You see that these are very aesthetic images, but at the same time, you see here scale, which is linked to an exact height of the dikes, and this is why we can call this model an epistemic model. And we looked at every polder separately in order to understand how the existing situation is working. For instance, here we saw these pits, and the whole landscape has a cultural significance, of course. And in a second step is the design research studio that started in September and ends today. We centered our interest on Anosizat, which is at the crossing of 2 rivers, the Ikup River and the Sisson River. And we chose to work with 3 polders that are most degraded by brick mining. And so the question was, how can we densify adjacent areas, but also restore some functions to these polders 1, 2, 3. And here you see the same image colored by height with a focus on the dikes that were built. And in many cases, the dikes were used to build settlements on it. Here we are in a span of 5 meters, and there are dikes that are a bit higher, like the colonial dike that separates the 2 river systems, but then a bit lower dikes around it. And the second part of this topography is the field structure, which is compressed only in 3 meters. We see that polder 1, 2, and 3 have almost kind of a stepped logic. And each of these polder has 1 functioning exit for water at the moment. Then we integrated the idea of how to model this data and integrate new ideas by transforming it. We used Docker Fosso, which was developed by Ilmar, in his doctoral thesis. We made direct use of this tool and then tested this newly designed topography by running water simulations. Here again with wet scenario and a dry scenario. And the last step was then to recompose a full model that would be including different types of plants, new housing structures, and creating a new vision for the site. So this concludes my quick introduction, and now we start with the presentations.